So many thanks to Miroslav, our organizers, to give us the opportunity to show today one of the products that we have made in Accenture. And I would like to start with the following. How many of you have had the chance to always repeat, when you interact with the system, always repeat what you have to say, even though you interacted before with that? This is it, exactly, yeah. So this is happening quite often still nowadays, but with the emergence of Gen AI, LLMs, and so on, this has to change, yeah? And that's why the data says nowadays that 80% of the customers, regardless of the brand, they're expecting to have a new experience, yeah? They're expecting to have relevance out there because people know nowadays that LLMs are powerful. They have seen ChatGPT and others, how they can interact with them. Therefore, we really believe that the relevance, it's really something that should change the way brands are interacting with the customers and the way we as customers, we interact with the brands. Today, together with me, I'm Catalin. I'm head of AI in Accenture, what we name AI and ML domain lead, let's say, in the Central European East countries. With me, I have Stefan, who is one of our greatest tech leads out there, and Miro, who is our senior AI engineer, who worked actually in this product. With the LLM and Gen AIs out there, we started 2 years ago to really build the relevance, and started with the automotive industry. And we started to build different touch points out there to change the experience that people are actually interacting with that. And this is where we started to have conversational configurator, so that it's not just like you do today when you go to buy a car, that you have to always have that kind of form out there that you have to fill in. We also did AI-driven sales support, so that it's really supporting the sales process. We did Gen AI in vehicle, so in-car Gen AI out there and AI, which nowadays can, and at least even at that point was possible, but also conversation after sales. So we try to touch all the touch points out there, yeah, but we have identified, once we had this isolated, let's say, enhancements in terms of the experience and even relevance is isolated, we have figured, we understood that this has to be connected, yeah, and then this was one of the biggest problem statements that we have at that point, how we connect them, yeah. So our ambition to really have a real, truly omni-channel experience was basically to have this kind of brand consistency, to make sure that if you are interacting with one touch point of that specific brand, if you come to the same or maybe to the next touch point, you have the same seamless experience, you can continue the conversation. It really feels like the brand knows you, yeah? Knows exactly what you want based on the interactions that you have before. Therefore, we started to build what we name today brand brain. Yeah? So it's really this relevance engine that usually comes on top of the existing systems of the enterprises out there to really boost the experience and change the way people are interacting with the brand. Yeah? That's why we have this, and this brand brain, what we name this customer experience relevance engine, comes with several parts out there. One of them is what we name brand brain agent, which is an orchestrator in the end of the relevance. You have so-called touchpoint agents, and then here we have a network of agents that it's really touch every interaction and touchpoint that you have with the brand, especially in the automotive, because this is the focus of the brand brain at the moment, even though this can be mapped to any industry out there. Yeah? And of course, the biggest, besides the multi-agent network, it's powering brand brain, we have a so-called behavioral knowledge graph, which is actually capturing the interactions of the customer cross touch points, and it's summarizing them in a way that you can derive relevance out of that. Everything comes on top of the current enterprises systems, that it's really meaningful, and enterprises can really take it easily to integrate. this is just a summary of how brand brain looks like, and that's why I would like to hand over to Miro to really show you how this is actually looking, and then Stefan will show you what it's actually behind the scenes. So Miro, stage is yours.
Yeah, thank you. So, how this is working in practice is in those few steps that you can see right there. So, if you are communicating with any of the channels, so either it's going to be a chatbot, or it's going to be a configurator, or are you going to have a conversation with your car during your daily commute or whatever, it's going to communicate with the brand brain. That means that omni-channel approach is going to gather all of the information into the brand brain graph database, where it is going to get stored. And once those preferences and those interactions are being stored, then we can retrieve them to give you the best recommendations we can based on what you think, do, or based on your behavior and also your conversations. Each interaction can be passed from channel to channel seamlessly because it's also connected to the same brand brain, which is going to think the same. And thus, it's going to recommend based on what you previously told it to. And we also have a demo, which is going to be just a video because we had little hiccups in the morning, so we are a bit sorry, but it's going to be grand nonetheless. So this is our car. This is our car configurator, and on the left we have a control center. And as you can see, I just talked with it like, hello, recommend me a car, please, because this is a car recommender and configurator. And you can see on the left side, in the log window...
Working with your preferences for luxury and performance, I recommend the A-Car A1. It has an AWD drivetrain, hybrid fuel type, and a stunning coupe design, ideal for a luxury status seeker like yourself. Would you like to configure your A-Car A1 further or explore color and rim options? If you're interested, I can also help you book a test drive.
Yes, so why this is happening? Because we have a persona, which is a luxury status seeker based on our previous interactions. I just picked random. And based on this, we got this car, and now we are going to configure it and give it some hints about what we like and what we don't. So I'm a big Bayern FC fan. Do have some colors that will align with it. On the left, you can see that it's thinking what is coming up with.
Working with your preferences as a Bayern FC fan, the standout match would be the red colour. It perfectly aligns with the club's signature colour and looks striking on the A-Car A1. Would you like to see rim options with this red or book a test drive?
On the bottom left, there is also the operations in the graph database as well that it got that you want red and white because that's colors of FC Bayern. And also, I would like to book a test drive, so this is a functionality that the application has.
I'll arrange everything for you.
It will ask us also the date and time.
Your test drive with the A-Car A1 in red is scheduled for tomorrow morning at A-Car Automobil München. You'll receive a notification on your phone with all the details. Would you like to continue configuring your car or need any further assistance?
Yes, so it also connected to our mobile phone, and now our mobile application, which is a different channel, is going to also be recommending us stuff. So hello, it happens that my family is getting bigger. Can you recommend me an upgrade, please? And let's see what it's going to come up with, because we have some kind of sports car right now. So on the left, you can see what it's thinking about and what it does.
Based on your growing family and your preferences, I recommend upgrading to the A-Car SUV. It comfortably seats 6, features luxury leather seats, AWD for all-weather confidence, and offers plenty of storage options for your expanding needs. If you'd like, I can suggest compatible storage accessories like a roof carrier, ski box, or bike rack to maximize your space. Just let me know.
Okay, and if you are going to click on the A-Car SUV that it's recommended, we are going to get back with a car that it recommends with the color that it already knows we like, because we like the FC Bayern and it's the same color. So that's pretty much all that our brand brain does right now, just for the automotive use case. And yeah, so how does this look like on the background? I will pass the word to Stefan.
Thank you. Can you hear me? Okay, so I need to keep it closer. Good. So, after hearing Catalin's introduction and seeing the demo from Miro, we understand what our mission was. We needed to build a solution that can unify all of the brand's touch points and basically connect those touch points with the brand's internal backends, services, tools, and data. And as you already know, we call our solution the brand brain, and we think of it as a relevance layer that sits between the touch points and the brand's internal backends. And if we zoom in a bit on this layer of relevance, we can already see that there are two main components, logical components at least. The first component is the brand brain reasoning, which is basically a multi-agent system that orchestrates a series of touchpoint-centric, brand-centric, and customer-centric agents in order to basically construct and maybe orchestrate a conversation between the agents that reaches context-aware recommendations that are communicated to the user in a consistent brand tonality. So whatever the brand decides that their tonality should be, that's how we communicate them via the brand brain across all of the touch points. And then we have the second layer of the brand brain, which I argue is the most important one, because this is where the relevance comes from, by the way. This is the brand brain memory. And right now it is a graph database. We call it the customer shadow graph. And it records information about the user's preferences as they have been expressed across all of the touch points that they have interacted with. So just to give you we'll get into detail more a bit more later, but to give you an overview, it is basically fed with user interactions and past conversations, and it turns those types of information into a kind of a mesh of nodes and edges onto the graph that represent how the user relates to the brand's offerings and the touchpoints contents. And below the brand brain, we have, just quickly and briefly, we have the connectivity layer. I want to mention it because usually, integrating a product into an existing and mature ecosystem is kind of the most painful part of our job. But in this case, the system we are trying to integrate is basically a multi-agent system. So we are lucky in that sense because we have a way to ease the pain of integration via MCP. So MCP servers for all of the internal backends, we standardize the communication and so on. So what we see on the graph is a high level, on the slide, is a high level architecture of the brand brain. But let's dive a bit deeper into it and see how it works behind the scenes. The first layer of brand brain that we are going to look at is the reasoning layer. And as I said, this is a multi-agent system. Its aim is to provide context and preferences-aware recommendations to the user in a unified tonality. Now, let's imagine the following scenario. You are a customer of one of your favorite car brands, and you are looking to buy a new car, as we've seen in the demo, actually. The usual flow, you go to the configurator, you visit the configurator of the brand, you pick up your favorite car, and you start configuring it with your preferred options. Maybe at some point you are prompted by the configurator or the chatbot on it to pick a color for your car. Now, you might not have a specific color in mind, or maybe you're undecided, or maybe you are looking for an aesthetic rather than a color. So you might say something like what Miro has shown in the demo. I'm a huge FC Bayern fan actually, so I'm interested in something that resembles that. So what will happen next is that the entry point in the brand brain is first the orchestrator agent, which will always pass your request to the moderation agent to ensure that it is compliant with the brand's internal regulations. After that, the orchestrator agent will try to identify if you have expressed any explicit preference into your request. In this case, you did. You mentioned you are an FC Bayern fan. So it will go via the app or activate the preferences agent and ask it to update this preference onto the graph. Then, once your request has been validated and your preferences have been recorded onto the graph, it will go to the agent that is specific to this touch point, which is in this case is the configurator agent, and it will ask it for a recommendation. After this step, the recommendation is a two-step process. First, the configurator agent will ask the customer shadow agent, which communicates with the customer shadow graph, right, the brand brain memory, to take a look at the graph and see if you have, any past recorded interactions with the color nodes on the graph, right? Context-aware recommendations. We are looking only at the context of color nodes. Additionally, it will also take a look at your persona that Miro was mentioning. So you, as a user, you might be aligned with a user's segment, for example. And it also takes a look at your user node where we store, fun facts about the user. So the customer shadow agent will contextualize all of this information. It will create a summary out of it. And basically, it will create a user characterization in the context of color picking. Right, it asks the customer shadow agent this, and the customer shadow might reply with something like, well, pragmatic buy and fun might actually like the red and blue colors. Which one do you recommend? Now, so far, with this summary, the next best action agent, which is always kind of difficult to say, so I'll just say NBA agent, we'll need to provide the recommendation. We'll need to kind of figure out which of these options to provide to you. But it receives at the input only the user's preferences. But that's not all we care about when making a recommendation. We also care about the brand's preferences. Because, for example, let's imagine in this scenario that, the brand, for example, might have a stock of bright red cars at the dealership near you, and it just wants to accelerate the sales of that stock. So out of those two options, that you prefer, it will actually prefer the bright red one because it's on sale, for example. Now, finally, before responding to you, the orchestrator agent will ask the moderation agent to rephrase the reply into the tonality specific to the brand, and then reply to you with something like the bright red screams buy and fun, and it is actually on sale. Good. So we've seen so far the normal recommendation flow of the brand brain, where it doesn't really know anything about you. But actually what the brand brain, what it does really well is this cross-touch point transfer of knowledge or of preferences. And how does it do that? Well, let's continue that scenario that we were discussing earlier. Let's imagine that you bought a bright red car, and you already own it, and you are at home and going into your car, and you have installed the brand-specific mobile application that you can use to interact with the features of your car. So out of convenience, you might ask the mobile application, "Can you turn on the ambient lights for me?" The flow is the same then. It will take your request to the moderation agent to validate it. Then if you have express preferences, it will ask the preferences agent to update the graph. But then it will go to the mobile agent this time, which is the touchpoint specific agent, and it will try to get it to turn on the lights for you. But when trying to call the tool that actually turns on the light, it will have a missing parameter, which is the color bit, right? So it will proactively ask the customer shadow agent to again take a look at the graph, see if you have any preferences regarding the colors. So the customer shadow agent will look at the same color nodes that we've seen previously, and it will see that the red and blue already have some increased preferences for this user. So this summary will be sent to the NBA agent, and let's say that the NBA agent, because it sees that onto the graph that you already own the red and you are looking for an FC buy and aesthetic, it will recommend the blue ambient lights. So, I don't know. Rephrasing the response, sending it back to the user. And that's kind of it. Now, there is another thing that I want to talk about. So we've seen two examples of user journeys on the brand brain, but we're still missing a few things in order to understand the full picture. I've mentioned earlier that the customer shadow graph stores the preferences of the user, and we've already seen one of the ways that this graph gets updated with the preferences, in the sense that we have that preferences agent which will update the graph with the preferences that the customer conversationally transmits to the brand brain. But we see that on this slide, that same preference agent is actually called explicit preference agent. So why is that? Well, actually, because we have another way of updating the graph, which is the upstream pipeline that we see at the top of the diagram. And the role of that pipeline, basically, is to translate all of the user interactions into preferences that are stored onto the graph, actually into preference scores that are updated onto the graph. Now, this is for the case in which the user might not bother to actually say out loud their preferences, or might not want to type them out, but rather they are more comfortable expressing them via clickstream data, by interacting with the touch point. Maybe they visit the same product every day, and this is a frequency that we can capture. Or maybe they configure this, the multiple colors all in the same color. Or maybe, I don't know, they schedule test drives with just electric vehicles and so on. All of this clickstream data gets updated into the graph by connecting relevance nodes to from the user to those specific nodes, and it increases some preference scores that help the brand brain during the inference process to gain kind of an intuitive understanding, of the customer and their preferences. Finally, one last thing that I want to say on this slide is the fact that one of the key requirements we had when designing the system was that it should be scalable in terms of use cases, right? So that's why we have a one-to-one relationship between the touch points and the touch point agents, so that if at any point the brand decides to integrate another touch point into the brand brain, then all we need to do is to create a touch point agent for it and make the orchestrator aware of it. And that's partially true because then we need to also do another thing, which is to create the touch points ontology onto the graph, but I'll get to that in a bit. Good. Okay, so finally, the brand brain memory. This is basically the preference score, the relevance driver, and it is what connects the user to touch points and the touch points to other touch points in order to make sure that the brand brain's reasoning layer has access to a continuous stream of historical preferences that the user has expressed with the brand as a whole across all of the touch points. But why is it a graph, though? Like, why didn't we go with another type of data representation? Well, that's because we actually care a lot about the relationships between different modular, reusable, basically, entities. And we care that those relationships should be named. Because you can imagine an LLM, it's much easier for it to understand, if you tell it there is a customer node and there is a color node, and they are tied together by a preference edge. Then that's intuitive to understand even for an LLM what it means. At the same time, if we were to design the same kind of data store solution in, for example, in SQL, right? It's a relational database, relationships. It's in the name. We would have to design the entities to be so modular in order to achieve this level of granularity that we would actually, at the end, we would have a data model that actually looks like a graph. But we would be in charge ourselves of managing those relationships on the application side. Instead, when having a graph, you are embedding all of these relationships onto the graph. Good. So lastly, this is a slice of the graph. And it is an applied slice on the use case we've seen earlier, because the graph actually, in reality, is a lot uglier. But we can already see, I hope, that we have two types of overlays onto the graph. The first overlay is the touchpoint ontology graph, which I've mentioned earlier. These are the green, blue, and yellow nodes. These represent how the touch points are connected to the products and the offerings of the touch points inside of the brand. Now, for example, for the car configurator, we might have an electric vehicle named A-Car Electric, which can be configured with as an exterior paint job with the red, black, white, and blue colors. Now, 3 of those nodes are also connected to the ontology of the mobile touch point, mainly because we can't have black lights. But So the red, white, and blue colors are connected to the ambient light control of the mobile touchpoint. So by sharing this overlap of the ontologies, we make sure that when we record a preference for a specific user, that preference is also made available to all of the touchpoints that have an ontology connected to that node. And the second overlay that we have is the user preference overlay. This is basically what we have on the left-hand side, where we have the user node connected to the touchpoints or the brand's offerings all over all of the touchpoints. And also, besides the user node, we have that persona node. So what happened during the second user journey that we saw is that the customer shadow agent took a look at the context in which it was trying to achieve something, as in it looked at the ambient lights control, it retrieved the color nodes that are part of the ontology, so only the three ones, red, white, and blue. And then it took a look at what connects the user node, Marco Rossi, with all of these three touchpoints. And it saw that there are two preference edges with implicit preference scores, somewhat increased. So it filtered those preferences, it filtered those nodes, and passed them on to the next best action agent, together with the persona of the user and the fact that the user is an FC buy and fund, which was stored on the user node. And that was basically it. So this is, I think, at this point we have the full picture of how it kind of works in the backend. That was me, and I will pass it over to Catalin for some closing remarks.
Thanks a lot, Stefan. Can you hear me? Fine. Okay, good. Yeah. So just to recap a bit, as you have seen from Miro and Stefan, we really took this relevance serious, especially into the automotive, because let's say we are more focused into the automotive industry. And we started with this question, how we make every interaction count, right? That was the first question. And we said, let's use the current technology that we have, which is multi-agent. So everyone talks about agentic AI nowadays, but also knowledge graphs, which we believe that the knowledge graph is not used at the full potential. That's why with this, what we call omni-channel intelligence / brand brain, we wanted to prove that the combination between multi-agent system and a knowledge graph behind the scenes can really drive relevance. And relevance at scale, because knowledge graphs are also scalable databases out there. Multi-agent capability gives you this chance to connect isolated touch points or capabilities out there into a system that really evolves and really starts to know who you are as a customer, really gives a competitive advantage to the brands out there which are keen to take such ideas, right? And it's not only about, let's say, the relevance in a way, right? But it's also about the experience that it's bringing behind. Because people are, as we said at the beginning, they are really expecting experience. They know already ChatGPT, yeah? It's already giving you a different type of experience. So that's why we are trying to bring this new experience to the brands. We started with automotive, right? And that's why we strongly believe, that this relevance, it's the new horsepower, that it should be there across brands, across industries. This omni-channel intelligence, how we name it here, it's the one to really prove, and it's already proven, let's say, this increase of engagement. Yeah, we have seen with some brands already where we started to discuss and so on, and they have parts of this one, more or less, that this already shows value, but not at the full potential. And that's why this omni-channel intelligence comes here to really leverage that potential. That being said, this was Brand Brain, let's say relevance at scale. Many thanks for your attention. So we have some questions, right? What are the retail-focused use cases you can share, please? Telecom, banking, other. Yeah, we cannot share. No, just kidding. I mean, there are some discussions in this retail-focused as well, right? Especially banking. But this is currently it's a highly regulated environment, right? And if you think about recommendation in this scenario, this is risky, and that's why we started with the automotive because here you have a different type, you can bring a different type of experience much easier, right? But discussions are, but not that much. Yeah, let's put it in this way. Hope I answered the question. Okay, maybe you mentioned that, but based on what will the agent remember at all the info, some login? What if the user loses her phone? What about GDPR? Yeah. So there is one thing about the user. So you have these two ways. I mean, two paradigms in a way. You have a new user out there that you don't know at all, right? It's not login, and of course everything is pretty much tied in a way with the login, right? Once you start to know the person, but when you don't know the person at all, then you have the personas, and that's why we made the architecture in such a way that takes care about first from persona perspective, and then try to put the user into certain cluster, and then work from that. And from there you can evolve your own customer profile. This is how it's called. Yeah. So this is how we started to think about this, because we know not everyone wants to log in. We know that's the biggest struggle nowadays of all the brands. When you come to an automotive, let's say, brand out there, and you want to just look around, you don't make a login. You don't make an account to go there to search for a car, right? No one does this, and we know about this. That's why, based on just a couple of interactions, and especially based on the, let's say, marketing analysis that it's behind this. Yeah? You may come to this one because you have seen a video or marketing advertisement that you were targeted with. And this is something that you can backtrack. And this is something that Brain can take in. What we name here, and it's also a product of Accenture, by the way, which is called CDIP, so the customer data IP, let's say, where we take this marketing intelligence into the BrandBrain. So that's one of the sources, let's say, of the data that we can feed in BrandBrain to give already this assignment of the current customer or session towards a certain persona. And this is how you can get more personalized experiences. Yeah. In terms of GDPR, of course, I know there are different regulations out there. One of the things that we, let's say, in the current stage of the BrandBrain, we haven't taken that one yet in the current stage. Yeah, BrandBrain is still in let's say it's the first version of the BrandBrain out there. But we, in terms of the GDPR, we want to anonymize. So we mainly want to work with anonymized information out there, and that's why profiles, these personas, are, let's say, a bit of the center. Yeah, and then you evolve from persona. We don't start with the actual user out there that we capture all your stuff. That, and of course, yeah.
Just wanted to add also that on the right. Am I audible though? Am I audible without a microphone? No? Or yes? Okay, I'll take the microphone away. So one thing that I wanted to mention on this note is that if we don't have a user that is logged in, then the BrandBrain can go into a persona discovery phase, because the persona is a user segment, as we said. So we don't really care at that point specifically about the user preferences, but we still might be able to provide some meaningful recommendations because we have some persona nodes onto the user. So the session of the user will replace the user node on the graph. The session node is connected to the persona node. That's one thing. And for the GDPR stuff, technically we are opt-in, opt-out, because the graph only stores the user-related information on the user preferences overlay. So we just need to delete the extract from the graph, the user node, and all of the edges that derive from it.
Yeah. Yeah. And it's just to add on top of that, in the graph, it's actually an abstraction of that. Yeah, it's not the real data, it's actually an abstraction. And that's why with this opt-in, opt-out mechanism, you can just even delete the abstraction specifically to that user. Yeah? What I want to also mention before we go forward to answer the questions is that we have multiple touchpoints. We haven't showed today in the video because we said it's too long. It's actually, the demo is like 10 minutes out there. We have the in-car as well. We have this new persona, that flow, let's say, that Stefan was mentioning, to discover what kind of persona are you out there. Well, but we haven't showed everything. We were planning to show you, but because of issues, let's say, Yeah, tonality issues, yeah, like ChatGPT did, yeah, probably you know the recent news. So that's why we weren't able, and apologies for this. Good, now going forward, how intelligent does the model behind content moderation agent have to be, since we're waiting for it twice on each request? Yeah, that's a really good question. I mean, the content moderation there has two main responsibilities. One is to ensure what ChatGPT haven't done recently. That's one thing. Yeah. Second, it's the to make sure that the communication that you get out there, it stays into the brand tonality. Yeah. Regardless of the touch point, you have to discuss with the brand exactly in the same tonality, and each and every brand has its own guidelines. Yeah. So if there are people from marketing here in the room, they know exactly what I'm talking about. I'm not a marketing guy. I just got to understand with the brand what that means. But this is the kind of responsibilities that the content moderator agent has. In terms of capability, how intelligent has to be, I think it's really depending, because there are two responsibilities. One is the safety checking part, and you have different mechanisms to do the safety checking. You can use an LLM behind the scenes. You can use a classical machine learning model to do this kind of classification tasks that are out there, and that's why it's always a hybrid approach. While in terms of brand tonality, it's actually a rewriting of the answer to stays in that one. Yeah, and this rewriting can be done with even a small model. Yeah. So currently we have a latency. If we think about the non-functional requirements of this one, in terms of the performance, I think we're answering today in less than a second usually, or even at some point maybe 2 seconds, depending how big it's actually the answer. Yeah. So it's not that big. It's still manageable. Ideally we want less, but we're working on optimizing that one. Yeah. So that's why in the brand brain there is actually multiple LLMs used behind the scenes, not just one. Yeah, some smaller, some a bit bigger, and so on, depending on the task that you have to do. Good. What advantages has the GraphDB over standard vector DB for this use case? Yet another good question. So the GraphDB, as you may know, the GraphDB, it's there to really bring the deep relationships between the different entities that you have out there. If you go, and let's take the example with the vector DB, if you go to take the vector DB, all the data that you put out there will be stored in a so-called, in a form like a vector, and then you have to keep to identify distances, to calculate distances between those vectors. But we also know that these distances, they are there to, of course, give some semantic, or give you the semantic relationship between those tokens, let's say, that are out there, but they don't give you the relationship. And that's exactly the problem. The graph database, it's coming to bring you that relationship that you usually need, because once you have a graph out there and you can connect all those entities, you can basically, giving it to an LLM, you can have better reasoning on top of what a recommendation agent can give back, or having a recommendation algorithm and a hybrid approach where you have a reinforcement learning algorithm plus an LLM. So the advantage stays actually in the fact that you have those deep relationships that you can model differently than in a vector database, where the relationship is just word or token semantically related in a way. Yeah?
I also wanted to add here, sorry. So it also matters on the performance of retrieval, right? Because we care about contextualized recommendations, contextualized conversations. So when we talk about the GraphDB, if you are on a touch point and you are configuring a color, then it's easy, you know exactly, you don't need an LLM or a semantic search, which is less deterministic, to know that you have to go on the graph to fetch the color nodes. But if you do semantic search, you might have some similar entities, at least in terms of semantics, into your database, and you might, sometimes miss the context. So it's kind of a bit more safe, I would say, to go with something that's deterministic.
Good, thank you.
It's time up. So thank you very much for your presentation, Catalin, Stefan, and Miroslav. If you like